Alrighty, I am beginning recording, so if we can make sure there is no devices that is hindering that sound, that would be awesome. Alrighty, so I am going to begin recording right now, so I will put this in the daily agendas. We are going to be talking about covalent bonding today. So we've already discussed ionic bonding. Um, and when we talked about ionic bonding, we made sure that we understood that ionic bonding was the process of electrons being transferred. And so now we're going to talk about covalent bonding, which is electrons being shared. So the essential question is, how do atoms form bonds by sharing electrons? And so that is going to be the purpose of this lesson, with that keyword being sharing. So the key vocabulary that you need to know for this lesson are nonmetal and valence electron, because covalent bonds, once again, when we talked about the three different types of of chemical bonds, we said you had ionic, metallic, and covalent. The differences between ionic and covalent were covalent was a sharing of electrons between nonmetals. Ionic was a transfer of electrons between metals and nonmetals. So it is very important that you understand that covalent only deals with nonmetals. It only deals with nonmetals. And reminder of what a nonmetal is: it's an element that lacks metallic properties except hydrogen. They exist on the right side of the periodic table. So they're going to be in that group 15 or 5A, group 16 or 6A, group 17 or 7A, and all of the noble gases, because it's in the word, noble gases. Alrighty. So moving on to topic question. Moving on to topic question number 1. We are first going to talk about what a Lewis dot diagram is. When you did your ionic bonding diagrams yesterday, and you had to show the transfer on the sum it up from the metal to the non-metal, whenever you were showing an ionic bond, let's pay attention, guys. I hate to do this on my recording, but we should not have cell phones in our hands. Thank you. Alrighty. So when you did that, you were drawing a Lewis dot diagram. We talked about this briefly. Whenever we talked about this, I think when we were doing electron configuration. A Lewis dot diagram is only going to show the valence electrons of the atom, the outermost electrons. So you cannot have any more than 8 valence electrons in that outer shell. So that is what a valence electron is going to look like. We have constantly talked about valence electron amount. So valence electron amount, you know the valence electron amount based off of the group on the periodic table. Okay, so group 1 has 1 valence electron. Group 2 has 2 valence electrons. Group 3 has 3 valence electrons. Group 4, group 4, Group 13, 3 valence electrons. Group 14, 4 valence electrons. Group 15, 5 valence electrons, 16, 6, 17, 7, 18, 8, okay? So because you cannot have any more than 8 valence electrons, I don't want to hear anyone saying group 13 has 13 valence electrons. No, that can't happen, okay? You cannot have more than 8 because 8 is a full shell, all right? So a Lewis diagram only shows those valence outermost electrons of the atom. So for example, oxygen will have 6 valence electrons, hydrogen will have 1. It's important that you only focus on the outer electrons because that's the ones that's doing the bonding. Okay? The inner electrons in those earlier shells are not bonding. The only ones that's bonding is those outer electrons. Okay? I'm going to stand up because this chair makes me record. All right, so at this point, I want you, and you should be familiar with this because we did this yesterday. This is your do now. You're going to draw the Lewis dot diagram for the elements. So you have fluorine. First of all, fluorine has how many valence electrons? 7. Nitrogen, looking at the group number, nitrogen has 5, and carbon has. So I just want you to briefly draw the Lewis dot structure for fluorine. Alrighty, so once again, we are drawing those Lewis dot diagrams, and that is just going to be composed of those outer electrons. So you should have looked at the group number. I mean the valence, the valence electron amount, and then that is what you should have drawn as your Lewis dot structure, making sure that you pair up those electrons as needed. So now we're on topic question number 2. What is a covalent bond? So that's what the next question we're on. So a covalent bond, this is whenever you are going to have atoms sharing. And so you can remember this by the prefix co, CO. Covalent bond, this is the topic that is going to be in regards to atoms being shared. So when you think of the prefix co, you should think of joint, partner, share, together. So that is what covalent means. And then valent is the cooperation or the sharing of valent electrons. Okay? So your valence electrons are being shared. I see this a lot, okay? A lot of kids are comfortable with ionic, they're comfortable with covalent, but then when you mix them, they get confused. The main things you need to focus on to determine if you're dealing with an ionic or a covalent is, does this have a metal in it? If it has a metal in it, it is not covalent. It is ionic or it's metallic. If it has non-metals and metals, it's a ionic bond. If it's strictly metals, it's a metallic bond. But if it has a metal, it is not covalent. So that's what you need to be looking for. Do you see a metal? Don't guess. Use your periodic table to determine that. So the next part of topic question number 2, it says a covalent bond, which is also a molecular bond, is a chemical bond that involves the sharing of electron pairs between atoms of non-metallic elements. So non-metals, once again, are sharing those electron pairs. So when we did ionic yesterday in the previous days, we showed a transfer of electrons. Covalent does not have that. Alrighty, so still on topic question 2. This is how covalent bonds will look. Remember, on our 3 types of chemical compounds notes, so the word molecules, that was on that worksheet that those notes we did when we talked about the 3 different types of bonds, and we said that you can refer to covalent bonds as molecules. So even though molecules is used loosely in chemistry, it only should be referring to covalent compounds when you have a sharing of electrons. So this screen shows an example of some covalent bonds. Oxygen, so all diatomic elements have a covalent bond. If you don't remember what the diatomic elements are, that was in those atom doodle notes that you received. All diatomic elements, which is those elements that occur naturally in nature with 2 atoms, those are going to be covalent bonds. So oxygen is an example, okay? Carbon dioxide, that's a covalent bond. Water, you can call it dihydrogen monoxide. We'll learn about naming elements, naming covalent bonds. It's very easy, shortly. So these are some examples of those covalent bonds. So just make sure in your doodle notes you write the name of these molecules. The last part of question number 2 is just reminding you what a molecule is. So for many molecules, the sharing of electrons is going to be the reason why they're able to obtain a full shell. Once again, what's the purpose of all of this bonding? Covalent, metallic, transferring ions, sharing on ions. What is sharing electrons? There are no ions in covalent bonds. What's the purpose of sharing or transferring electrons? The purpose is they are trying to get a full shell. They are trying to get a full shell. Once again, they are trying to get a full shell. I don't care where we leave off today. We will be doing a painting activity tomorrow, definitely. And it has to be due tomorrow. It's 100 points. It's going to be due tomorrow. Okay? You are going to be, every person in here is going to be doing something different. Okay? So we are going to be taking our knowledge of ionic and covalent, and we are going to be working, and we are going to be decorating our class wall for covalent and ionic. And we're going to be adding to our periodic table. Okay? So let's move on to topic question number 3. Let's move on to topic question number 3. And this is why I like doodle notes. We already halfway there, and we just started. Okay? So topic question number 3, once again, what is topic question number 3? What is the octet rule? The octet rule, this is a rule of thumb that says that all elements, the atoms of main group elements, they combine in a way that each atom has 8 electrons in its valence shell, giving it the same electron configuration as noble gases. So remember, the noble gases have a stable electron configuration. So stable that we have noble gas configuration that we do on its own, that we use to shorten electron configuration that you learned about. And you guys did a good job. Also, FYI, can you please keep up with your posters? Some of you did not tape them correctly and they are falling down. So if you are iodine or gold, please tape your poster correctly. It has fallen down. Also, xenon, your poster is falling down. And any other person, if you walk in and see your poster is not there correctly, just asking for some tape. And make sure that you're taping it in a way that's secure and not going to fall the next day. That's just a FYI. I just thought about it. Okay. So octet rule says that elements want to have 8 electrons in its outer shell. Either they're going to have 8 electrons because they have it on their own, like the noble gases, or they're going to have to share or transfer electrons in order to get it. And so that's the main thing you need to be thinking about whenever you're showing these diagrams. Still talking about the octet rule. Everything I said applies with the exception of hydrogen. With the exception of hydrogen, which only has 2 valence electrons in its outer shell, to reflect the electron configuration of helium. Okay, so remember, helium only fills up that first shell, that first M shell, and so hydrogen is going to try to follow that because that's the noble gas that it is trying to copy. Everyone else has 8 electrons, or was trying to get 8 valence electrons. Alrighty, we are already moving on to topic question number 4. We are already moving on to topic question number 4. So topic question number 4 is, what are bonding pairs? Topic question number 4 is, what are bonding pairs? So when you are drawing covalent bonds, you are going to draw them where you show the electrons being shared. And so bonding pairs are what we call this, when those electrons are being shared between atoms of molecules. They are like the handshakes that allow the atoms to complete their octet. So it's very important that you remember that for covalent bonds, you are showing the electrons still being attached to both atoms. Okay, they still have to be attached to both atoms if they are being used to show some type of covalent bond. The next part of topic question number 4 is going to show those actual diagrams that depict bonding pairs. So this is how you would depict carbon dioxide. So it may look like, what is this? But break down what I told you, right? First, if I say, show me a bond between carbon and oxygen, okay? What you would do is, or carbon dioxide, you would draw the valence electrons for each element, okay? So even though it might look a little confusing, oxygen has 6 valence electrons. Oxygen has 6 valence electrons. Carbon has 4. So for each of those, you are going to keep in mind that you want to have 8 valence electrons. If you look at that picture, oxygen, both of them have 8 valence electrons. I'll show you with my little pointer. Okay, I just circled where there are 8 valence electrons. And carbon has 8 valence electrons. So the way you bonded these elements allowed all 3 of these elements to now have a full shell. Okay, so what this picture is showing is carbon is saying, giving its hands out and saying, here, oxygen, I'm giving you my hand, shake it. And oxygen saying, okay, because I need it. Okay, and so there are 4 handshakes that are happening right here in order to represent a stable covalent bond with bonding pairs. So 4 handshakes are happening, okay? Carbon is saying, hey, each oxygen on either side of me, can you please shake my hand? I'm giving you 2 handshakes so we can be stable, okay? There are, these bonding pairs is allowing stability for this atom. And once again, just like I said with the ionic bonding practice, This is something you have to do. You cannot learn this by looking at it. You have to, and that's why I'm asking for your full participation. Your listening, your reading, your reviewing. You can't do that if you're distracted with a cell phone. Okay? So that's why I'm asking you, because when it comes to this stuff, just listening is not going to work. You have to actually understand it so you can practice it. Okay? All right, so you will have some bonding pairs that will not engage. So if you look at carbon dioxide, not all of the electrons in oxygen are bonding with carbon. Some of them are just strictly on oxygen. Those pairs are called lone pairs. So the pairs that are actually involved in the bonding with the other element, that is going to be called bonding. Um, your bonding pairs. And the pairs that are not involved in the bonding, these are going to be called lone pairs. So if you're looking at the bottom portion of question number 4, that's where you're going to find this right here. Now we're going to move on to question number 5. So how many bonds do atoms normally form? Okay, how many bonds do atoms normally form? So if you can remember this right here, I mean, you don't have to remember it, but because if you remember the rules of how to do covalent bonds, you'll be okay. But if you remember this right here, it will make it a little easier for you. It will make it a little easier for you. If you can remember, hydrogen normally forms 1 bond, oxygen normally forms 2, nitrogen normally forms 3, and carbon normally forms 4. HONC is a little prefix that tells you 1, 2, 3, 4, tells you how many bonds hydrogen, oxygen, nitrogen, and carbon form, along with the other nonmetals in their groups on the periodic table. So this is just a little quick thing. So if you can remember, okay, hydrogen's in here. I know hydrogen should be forming 1 bond. Nitrogen should be forming 3 bonds. So if you remember that, then it'll just be like a little shortcut for you to do those covalent bond images and diagrams. Now, this is kind of self-explanatory. If you have 1 bond, it's a single bond. If you have 2 bonds, it's a double bond. 3 bonds, a triple bond. Now, if you have hydrogen bonding, it's behaving like a halogen. It's behaving like a halogen, which is group 17. And let me see if I can get my toolbar. There we go. To stop blocking the bottom. So that's really easy. So hydrogen is going to behave like a halogen, and which is group 17. And then you'll see whenever you're talking about bonds, you can have single bonds, double bonds, triple bonds, and so on. And I'm very happy that we're already on topic question number 6, just because when we do our major daily grade tomorrow, what I mean by major daily grade, it's going to be a daily grade worth 100 points, and you are going to not work with partners. It's going to be independent. All right, it's going to be independent. When you do that, you'll have a strong foundation of the differences between ionic and covalent. Even if we don't get to finish the entire PowerPoint today, we've finished enough where we should be okay. Okay? So now we're going to talk about how do we represent covalent bonds? How do we represent covalent bonds? Well, we represent covalent bonds by first, of course, writing the atom and then doing the Lewis dot diagram. Remember, your Lewis dot diagram only involves your valence electrons. So let's say I wanted to say, how would the Lewis dot diagram look if you were combining 2 chlorine atoms? First, you would draw the valence electron of chlorine. The second thing you would do is rearrange the electrons and add additional atoms if necessary. This is how it would look. So you would rearrange them so that you can set them up to bond. Okay? So in that first picture, they were kind of rearranged a little kooky where you couldn't bond them, but you rearranged them now where they were on a side where they could bond together. Okay, so you're setting them up to be rearranged. Also, if the image requires you to draw anything, especially like question number 7, do it. The third thing you're going to do is you're going to circle the new valence shells. You're going to circle the new valence shells for each atom. So you want to kind of get an idea in your head of, okay, this pertains to this atom, okay? So that you can see where those bonding pairs are, where those lone pairs are. You're going to circle the new valence shells for each atom. Each shell will now have 8 electrons, except if you're dealing with hydrogen or, helium, but it'll just have 2, okay? So circle the new valence shells for each atom. Remembering if you're dealing with hydrogen, it's only going to have 2. Now you're going to write the element symbol. That should already be written. And you're going to draw in the bond line. So everywhere you see there is a bonding pair, you're going to represent that like a line. Okay? Just like in topic question number 4, where we show in 5, where we showed the single bond, the double bond, the triple bond. You're going to represent those as lines. Why do we represent as lines? Because some of these elements, especially when you get in these higher level chemistry, the organic chemistry, they're going to have a lot of bonds. So if you do dots, it gets confusing. But if you have lines, it makes it a little easier to understand. So you're going to write the element symbol and you're going to draw the bond lines. So you are able, so just bond lines though. So just electrons, bonds that's between the 2 elements, okay? You don't. And then now you can write the new molecular formula. So once you have shown a bonding between both elements, remember before you are comfortable with saying this is right, make sure that each atom has 8 valence electrons. Then you're going to write the new formula, okay? We're still on topic. Question number 6. It's the same thing. So how would you show hydrogen and nitrogen being bonded? So remember on that ionic bond yesterday, I think question 3 and 4, y'all had to add some atoms? This is what you're going to have to do for this one, okay? If you try to bond hydrogen and nitrogen, that's a problem because if you're trying to bond these two, that's a problem because even if you give this 1 electron right here on hydrogen to nitrogen, nitrogen still needs how many electrons? How many more electrons would nitrogen need? Anybody? 2. So you're going to add 2 more hydrogen atoms. Please draw what you're seeing, guys. It's very important that you can see this. So you're going to add 2 more hydrogen atoms, making sure you bond them using bonding pairs. Remember, what's the next thing you're gonna do, guys? What we just said. Once you have your bonding pairs and dots, like circles, what you gonna make them now? You're gonna change the circles to what? Look at your notes. Don't reel out random answers. Look at your steps. Once you did step 3 and you bonded it with circles, what's the next step that you do? Look at your notes. Don't yell out random answers. Okay, so you're gonna draw your circle. Good job. You said draw your circles. So I'm gonna be honest with you. Once you get the hang of this, you don't need to draw circles. Okay? But right now, while you're learning, you need to draw circles because when you draw a circle, it makes it easy for you to be able to quickly identify, are my shells full? And hydrogens are full. And the hydrogens are full because you have 2 electrons in the outer shell of hydrogen and you have 8 electrons in nitrogen. So they are full. The next thing you're going to do after you draw those circles to just remind yourself if you have a full shell is you're going to take those circles and those bonding pairs which is the pairs that go between both atoms, and you are going to transfer those to lines, making sure you leave your lone electrons still as dots. So it's easy for you to see your lone electrons as compared to your bonding electrons. Write your formula. This is an example of ammonia. So the ammonia that you use to clean, this is that. And that is it. We've learned covalent bonds. So if you felt like I moved too fast, you need to review. This video will be in my YouTube. It will also be linked in the daily agendas. So please use this video to help you to answer the sum it up questions. Also remembering all do now questions are due. And if you have any questions, I will try to upload any extra resources in our Schoology folder in the chemical compound covalent bond folder.